For a salient pole synchronous generator, the perfect reactive power in terms of power angle delta and for a lagging power factor is given by. Okay, we have to find the reactive power equation of a salient pole synchronous generator. Okay, in salient pole synchronous generator, the air gap is not uniform throughout the cross section. Okay, we have minimum air gap along direct axis, whereas maximum air gap across quadrature axis. Now, what is the phasor diagram for this one? The phasor diagram, let us take induced EMF EF as the reference. Now, what is the terminal voltage VT? Terminal voltage VT will be displaced at an angle, power angle delta, with respect to induced EMF E. Okay, since in question he mentioned about lagging power factor, so armature current IA lags behind the terminal voltage V. Let us take at an angle phi. Okay, now here this is at an angle phi. Now here this armature current will have direct axis current as well as quadrature axis current. So the resultant current, this one is direct axis current, whereas this one is quadrature axis current. Resultant is armature current IA. Now, what is terminal voltage VT? In series with VT, we have a drop of ID into XT. You can say this is J times of ID into XT, as well as this one is J times of IQ into XQ. Okay. So, induced EMF E is the resultant of terminal voltage VT plus, okay, this one is square root of I into Z. Okay, this is the drop of I into Zs. Now, what is reactive component Q? Reactive component Q is current and voltage component in quadrature. Okay, to find active power, it should be current and voltage in direct axis, whereas to find reactive power, it should be current and voltage in quadrature axis. Now, what is current and voltage in quadrature axis? This is IT into Vt cos delta plus IQ into Vt sine delta. Okay, now what is IQ here? IQ is given as Vt into sine delta by XQ, whereas ID is given as EF minus Vt into cos delta by XD. Okay, substitute these two values in reactive power equation. When you substitute these two values in reactive power equation, we can find out this is Vt EF into Vt by XT cos delta minus Vt square by XD plus Vt square into 1 by XQ minus 1 by XD into sine square delta. So option C is the correct answer. Which provides a path to the load current when switch is off in a chopper is, okay, let us take a chopper circuit, a step down chopper circuit. Here you have a diode and an inductor in series to the load. Okay, this is the load input to the chopper. Let us take this one as VD. When chopper is on, this diode is reverse bias. Current through the load, let us take it as I0. Okay. So initially, let us take this is having minimum value of current I minimum. This one as I maximum. Up to this point, this is on period of the chopper. When chopper is off, what happens is the diode is used to freewheel the current in order to have continuous current conduction. Since these are connected to adjustable speed drives, okay, so the current should always be continuous, otherwise the drive which is connected to the chopper, or you can say this load, is switched off. Okay, that means it will turn off. So in order to provide freewheeling current, that is known as through the freewheeling diode, so option A is the correct answer. This is called freewheeling action. So the diode which carries current, the freewheeling current is called freewheeling diode. Inverters are mostly used in adjustable speed drives. Okay, mostly. This is an important term you should observe. Okay, which of the following inverters are used in adjustable drives means the question is different. And which of the following inverters are mostly used in adjustable speed drives? So that means only one option should be the correct one in this. Okay, this D option directly you can eliminate it. Okay, now voltage source inverters, current source inverters, resonant inverters. Okay, resonant inversion depends upon the commutation, he has named it. Now what is voltage source inverters? We have constant input to the inverter, that is DC input to the inverter. Okay, this is voltage source inverter, whereas if you have constant current source at the input side of the inverter, then it is current source inverter. Okay, why we are not using current source inverter? There are many differences between voltage source inverter and current source inverters. Why we are not using current source inverters in practical situations is that generation of current source is very difficult, since we should have very large inductance connected in series to that of input side of the inverter. Okay, because of this, what happens is that there will be overlap phase angle. Okay, because of that poor power factor we have, and generation of current source is difficult, and one more is that losses will be more in current source inverter. That means efficiency will be less. That's why we are going to use voltage source inverters, because exact quite opposite advantages it is going to have when compared to current source inverter. So option A is correct answer. A UJT based oscillator provide. Okay, UJT is unijunction transistor. Now what is unijunction transistor? Unijunction transistor has two bases. Okay, its schematic diagram will be like this. It will have two bases. Let us take this as resistance RB1, and this terminal is base 1. Okay, and this is emitter terminal, whereas this one is, let us take base resistance 2, base 2 terminal. It has two base terminals and one emitter terminal. Now this is a UJT transistor. Okay, unijunction transistor. Now what are its characteristics having? Okay, it will have characteristics of like this. Okay, so what is this one? This one is called as peak point, whereas this one is valley point. Now this will conduct, UJT will conduct when it reaches this peak point. Okay, when it reaches this peak point, what is the response it is having? It will conduct up to only valid point. So you have sharp pulses. Okay, if you take some n number of pulses, okay, now let us take, this is the different pulses configuration we have. So every time you have sharp pulses. Okay, it is having sharp pulses, and the rise time here, it will be having very less rise time, whereas frequency is constant. Okay, it is having constant frequency. So all the above is the correct option.
Following transmission line shown below, the voltage at VAA dash will appear at VBV dash after a time interval of. See here, this is the DC signal, that is U of t. Here length is 300 meters. That is lambda is equals to infinite, because frequency is 0 for the U of t. If frequency is 0, so phase velocity is approximately equals to the velocity of light. So time is nothing but L by Vp, which is equals to 300 divided by 300 into 10 power 6, that is 10 power minus 6 seconds, which is 1 microsecond. That is option B is correct. Group 1 with group 2. Coaxial cable, parallel wave transmission line and microstrip line. In coaxial cable, shielding is provided, hence there is a low electromagnetic interference, whereas parallel wave transmission line is high electromagnetic interference. Microstrip lines are preferred in printed circuit boards, that is PCB. So 1 PE, 2 R and 3 Q, that is option B is correct.